Okay, guys, last time we left off, we were talking about our six trig ratios for right triangles and our special right triangle properties. Now we're going to be talking about angles of rotation and slowly working into the unit circle next section. If you guys would like to do the warm-up for this week, it's not going to be a hard copy. The warm-up's just on Schoology. Under warm-ups, you can click this. Chapter 10, warm-ups, click angles of rotation. And it's just a Desmos activity. You can ignore the middle school geometry. It's supposed to be easy. It's just getting you guys understanding angles, how angles of different degrees operate. And you can just click this student preview option and start working through the warm-up if you'd like. It's not required. If you want some more practice with angles and reflecting, this activity is using lasers, you can go ahead and do that messing around with angle degrees. Okay. For now, let's just start with our angles of rotation. When an angle is in standard position, and once again, guys, if you don't have these pictures, you can just pull them from, you can screenshot these notes and put them into yours, or you can just pull them from Google like I did. I just typed in angles in standard position. So an angle's in standard position when the vertex is at the origin, like we can see here. Go a different color. Vertex is at the origin, and one ray, remember an angle is made up of two rays meeting at a vertex, is on the positive x axis. Okay, and that would be talking about this ray right here. So the positive x-axis, the ray that's on the positive x-axis, is called our initial side of an angle in standard position. And then terminal side, you can think of finishing. The angle finishes on its terminal side, and that tells you really the angle's measure. And we know that our angles are measured in degrees. A positive angle rotation is what you have in this image. So positive angle rotation is an angle that rotates counterclockwise, like you can see here. A negative angle rotation is going to rotate clockwise. So we can have a negative angle rotation that would rotate this direction. So this looks like it's about a 135 degree rotation. You could also rotate negative 135 or something like negative 45 degrees. And now our terminal side would be opening down over here. And we'll have plenty of examples like that in just a sec. Negative angle rotation rotates clockwise. Okay, a couple more vocabulary terms here that we're going to be using for this section. Coterminal angles. Coterminal angles, hopefully you can see the two words that make up coterminal. Co meaning with or together, so this would be two angles, two or more, in standard position with the same terminal side. Okay, so I'll draw an example down here of coterminal angles. And then I'll put an image up for you guys as well, so you have that in your notes. And then we'll have you practice some, okay? So remember, the initial side always starts on the x-axis. So here's my initial side. Say we had an angle that was, let's say, 100 degrees. Here's a 100-degree angle. Well, we could also have the same exact angle and standard position if we rotated clockwise. Now this would have to be negative, and that's fine. This would be negative 90. Remember, horizontal and vertical lines, 90-degree angles. Negative 180 to form a straight line. And then this last part would be our negative 270, and 100 degrees is just 10 less than 270, so negative 260 degrees. 100, negative 260, both coterminal angles. They finish in the same position. You could also just add 360 degrees to your initial rotation, and now you would just rotate from the initial side once, 360 all the way around, and then back to where you started. So this would be 460 degrees. So 460, 100, negative 260. These are all coterminal angles. Same standard position with the same finishing terminal side. So I also want to put a picture on here so you guys can see another example of coterminal angles. And this example, just like the one I used, is rotating in the beginning here 45, and then you could rotate a full circle in another 45, so 360 plus 45 gets you your 405 degrees, or just going in the negative direction, which would be negative 315 degrees. Okay. So let's have you find two coterminal angles for, let's do 3 examples on here, 2 and 3. 120 degrees, let's do 80 degrees, and negative 135 degrees. So why don't you guys go ahead and pause this video. Find two coterminal angles with each of these 3 angles. Okay, go ahead. All right, so hopefully for 120 degrees, 120 is over here. It's 30 degrees past 90. So if you're going the other direction, that would be negative 180 and then negative 270, but it's actually 30 degrees less than 270. So negative 240 degrees would be a coterminal angle. And then you could always just add 360 or subtract 360 2 times to that original angle, where you just go around one full rotation and then the other 120 degrees. So 480 would have been another coterminal angle. Same logic for 80 degrees and negative 135. You guys, you can have different answers than what I have. You could have added 360 twice. There's an infinite number of coterminal angles you could find. For 80 degrees, I think just adding 360 and subtracting 360, you would have been left with negative 280 and 440. For negative 135, negative 495 degrees and 225 degrees. Okay, we'll continue to practice using coterminal angles on the homework and throughout this unit. Okay, another term we need to be familiar with are reference angles. Okay, and reference angles are just positive, acute angles formed by the terminal side and the x-axis. Okay, reference angles are going to be really important for finding the trig ratios of any angle measure. Okay, and you'll see why in just a sec. If I wanted the reference angle for theta, and theta was a 150-degree angle, well, following our definition, 150 degrees would be an angle in standard position that looks something like this, 150-degree angle. Well, the reference angle is the positive acute angle formed by the terminal side, this side, and the x-axis. So that would be right here. So this would be my reference angle. So for a 150-degree angle, the reference angle would just be 30 degrees, because 30 plus 150 gets us our straight line. And the reason we're going to be using reference angles a lot this unit is if I were to take the sine of 150 degrees, we get 0.5. Well, reference angles are nice because you could also just take the sine of the reference angle for 150, which is 30 like we found, and what do you notice? We get the same exact ratio for the sides of this right triangle or right angle that are formed. And you might not see the right angle yet, but you're going to at the end of this lesson. Right triangle that's formed. You get the same ratio of the sides that are opposite over the hypotenuse. Okay. Here are some more examples of reference angles in every quadrant. Okay. So I just gave us an example of a reference angle in quadrant 2. Why don't you guys do 2 examples? Find the reference angle for theta at negative 130 degrees and for theta at, let's do 310. Okay, you guys can pause the video. If you need to draw it like I did right here, do that. Go ahead and pause the video and find the reference angle. Remember, it's a positive acute angle formed by the terminal side, and this will get you the terminal side and the x-axis. Okay, the second example, you should have gotten 50 degrees. Remember, the answer is always going to be positive. It's always going to be a positive angle for your reference angle. And then for 310, you should have gotten 50 degrees as well. 310 is 50 degrees away, so that was this one in quadrant 4. And then this example up above right here was in quadrant 3. Remember, a negative angle rotates clockwise. Positive angle rotates counterclockwise. Okay, and what I'd like to finish with is going back to what we were doing last unit, which was finding trig functions for theta now on a coordinate plane when you're given a point. Okay, so why don't you guys go ahead and sketch a graph, and then together we'll plot this point over here at 4, -5. Draw our terminal side. Remember, this is the terminal side. This right here is our initial side. It's always the positive x-axis. Okay, and the 6 trig functions that we're going to find for theta, theta is going to be our reference angle. Hopefully you saw that in here when you just entered sine of 150 and sine of 30, and you can see you get the same exact ratio for both. Well, we're going to do the same thing on this coordinate plane when you're given a point located anywhere on that coordinate plane. So let's construct our right triangle like I was showing up above. go ahead and list out our length. So this would be 4. I know length is always positive, but for the sake of writing these trig ratios, this is down 5. And then we need the hypotenuse, right? We still need this length right here. Okay. And if we have a right triangle, we can just use a squared plus b squared equals c squared to get the hypotenuse length of this right triangle. Because we're writing all 6 trig functions, so we need the hypotenuse, for our sine ratio, our cosine ratio, and tangent, we're just going to be using these 2 lengths from 4 and the -5. That's okay. We still need to find this length right here. So plug in our 4 and our -5, we get 16 plus 25 equals c squared. 41 equals c squared. We're just left with the length of root 41. All right, let's go ahead and find our 6 trig functions. Sine of theta. Remember, sine is opposite over hypotenuse. So -5 over root 41. We can never leave a radical in the denominator. When we multiply top and bottom by root 41, we get -5 root 41 over 41. Cosecant of theta is just the reciprocal. So negative root 41 over 5. And we don't need to simplify anything there. Cosine of theta, adjacent over hypotenuse. And theta is always your reference angle, so the adjacent side is 4. Hypotenuse is still root 41, so when we simplify, we get 4 root 41 over 41. Secant of theta is the reciprocal of cosine, so root 41 over 4. Last 2, tangent. Tangent of theta is opposite over adjacent, so -5 over 4. And cotangent of theta, just the reciprocal, -4 over 5. Okay, so hopefully we are able to notice kind of a relationship here from the points that are plotted in angles in standard position. For a point on our coordinate plane, point P, x, y, that's on the terminal side of theta. Also in standard position. And the radius, this is really just r. It can look just like our radius going from the origin out to the end here. And you'll see why we call it radius next unit when we're graphing our unit circle. That length r just came from the square root of x squared plus y squared. Well, you're going to have these 3 trig ratios, and you really don't need to memorize these because for the most part you're going to graph these out and use your right triangle with opposite hypotenuse, adjacent hypotenuse to write these ratios. But it's good practice just to have these written down. The sine of theta is just the y-coordinate of over your radius. You guys saw that right here. Y-coordinate over root 4 over 1. Cosine of theta is the x-coordinate, the adjacent length over your radius, and tangent of theta is the y-coordinate over the x-coordinate. Okay? So let's have you try one example on your own. You can pause this video and find the 6 trig functions for theta when point P is located at -3, positive 6, all the way up here. And remember, theta is your reference angle. Theta is this angle. It's always going to get you the same trig ratios as this angle right here, whatever that measure might be. Okay, theta is the same thing. So go ahead and find all 6. Sine of theta, cosecant of theta, cosine of theta, secant of theta. Okay, you pause the video, work it out, and I'll put the solutions up in just a sec. Okay, hopefully for this length you were able to get root 45 after you did 3 squared plus 6 squared equals c squared or r squared, and don't forget to simplify. You need to pull out perfect squares, which would be a pair of 3's. So 3 root 5. So for sine of theta, that would have been 6 over 3 root 5. Just be careful on when you're simplifying here. Let's go, 3 goes into 6 twice, so you get 2 over root 5, which simplifies even further to 2 root 5 over 5. Cosecant of theta is just the reciprocal, root 5 over 2. Cosine of theta, negative 3 over 3 root 5, which simplifies to negative 1 over root 5, or negative root 5 over 5. Secant's just the reciprocal, so negative root 5 over 1. Tangent, 6 over negative 3 or negative 2. And cotangent, negative 1/2. Okay? All right, these trig ratios are all referencing the relationships formed in this right triangle. So still using right triangles, now just on a coordinate plane and using reference angles, because hopefully we saw in here the reference angles for any of these ratios, just like cosine of 150 gets us negative 0.86 and cosine of 30 gets us the same ratio, just one's positive, one's negative, and we'll talk about why there's that difference next section. But reference angles are just a quicker way for us to find these 6 trig functions, which are ratios between the side lengths in a right triangle. Okay, great. Go ahead and get started on the homework, and I can answer your questions during office hours.